All right. As it turns out, I did mispronounce his name. It's pronounced Niall. It's a cool name. We're going to have Niall Burkley talk to us about user-centered API versioning.
Okay. Okay, can people hear me? It works? Okay, cool. It's great to be here. It's quite a privilege to be up here among such good speakers. Thanks to Osa and Aaron for making it really hard for me to talk this morning with some great talks. Okay, it's nearly lunchtime, so just bear with me for a little bit and we'll get fed soon. But first, I would like to talk to you about API versioning. Okay, so versioning is hard. In my opinion, it's up there with caching and naming things. It's one of those problems that never really goes away. But I would like to talk about how we are versioning some of our APIs and trying to make life a little bit easier. So my name is Niall Burkley. I am a developer living in Berlin, Germany. I'm Irish, so that explains why I sound a little bit funny and why nobody can probably understand me. I'm working for Meltwater in Berlin. Meltwater are a media monitoring, media intelligence company. So we store and analyze a lot of data to help companies gain insights on their brands and their products. So we basically crawl a lot of publicly available information, we categorize it, and we analyze it, and we gain insights out of that information. For the last year or so, we've been working on the Meltwater API. And this is a client-facing API for the Meltwater data. And it enables customers to gain insights on their data and pull it into their products, pull it into their dashboards, into their BI reporting tools. But it's a new product for Meltwater. So we've had our application around for years, but this is the first time we're building an API around that. So we didn't really know what we were building. So we built it in an iterative development fashion. We would plan, we would build, and we'd test and gather feedback from that. And then plan again, get some more feedback after we build, and so on and so forth, using these iterations to figure out what we're building as we're going along. So along the way, we made lots of changes, we got lots of feedback. But the thing is, we're building an API. We're not building a website where we can just take things away and move things around. This is an API that people are depending on. An API is a contract. And when we are building an API, we're telling users it's something that they can depend on, something that they can build against, and that they can assume that it won't change. If we change that API, we are breaking that contract. We're going back on our word. The interface that we told users they could depend on, they can't. And any integrations that they've built will probably fail. And of course, our users are not going to be happy. They're going to be debugging their applications, wondering what's going wrong, what went wrong. But it turns out we changed something, we broke their integration. Yeah, it's not the ideal situation. So what do? We version our API. We keep the existing contract, we create a new contract, and we put all those changes into that new contract. So if users want the new features, they sign up to the new contract. They use the new version. So now we have multiple versions of our API. But that also means we need to maintain multiple versions of our API. So our complex business rules to get our data to the users have now become more complicated. And because this isn't the ideal situation, we tend to hold off on doing it. So we wait for 6 months or a year until we have enough features to create a new version, and then we cut a new version of the API. But saving up all these new features means that there's a migration plan to get from one version to another. So when a user has an integration and they want to upgrade versions, they need to change the last 6 months of changes or 12 months to get their integration up to date with the new version. And sometimes these can be pretty complicated. A lot of the time, people have to rewrite their entire integration or have to make a lot of changes just to get up to the new version. So a lot of the time, users avoid it until it's absolutely necessary, and usually until things actually break. So what's an alternative? When we were building our beta version of our API, we made lots of changes based on feedback, and we broke the API regularly. But it was a beta, so that was fine. But that wasn't going to work for a production application. So we tried to revisit how we were versioning our API to see was there a better way of doing it. We looked at things from a client perspective and from our perspective. So first of all, what would be better for the client? So users want an API that's stable. And this isn't just a bug-free API. This is an API that doesn't change, that if they build their integration, it's going to work, and it's going to continue to work. I'm sure you remember last year, I think, or the year before, Instagram changed their API. They removed access to user feeds, and that broke a lot of applications. I mean, this isn't a great thing to happen. Documentation is a pretty important part of an API. When you're building an integration for an API, the documentation are the instructions that you're using to build that integration. When there's multiple versions of an API, there's also multiple versions of the documentation. I'm sure many of us have been working on something and wondering why the hell it's not working when it turns out that we are looking at the wrong version of the documentation. I mean, it's really frustrating. So it would be great if the documentation that you're looking at is always the correct version for the version that you're using. Another thing that would be helpful for users is an API that's easy to upgrade. Rather than having to rewrite huge chunks of an integration, it would be great if it was smaller, more simple upgrades. For example, let's say I have an API and I'm getting an author. That's one of the fields I'm returning is the author's name. And instead of getting the author's name, I can now get access to the author's URL, their profile picture, a bunch of other data. But if I want to get that, I need to make all the changes that are necessary to upgrade to the next version to get that change. I don't care about all the other changes, but I need to upgrade everything to get those changes. It would be nicer if I could just do smaller, more granular updates. The other thing that we found is that some users don't care about versioning. Some of our users were getting third-party teams to build the integrations for them. They come in, they build the integration, it's working, they go away, it's fine. But then they have to upgrade 6 months, 12 months down the line. Some users don't care about versioning. They want to build their app integration, leave it running, and just forget about it. Obviously, we can't just consider things from a client perspective. It has to make sense for us as well. So we tried to look at what was working well for us for building an API. So one of the things that we really like is having an API that is easy to change. So we work in an agile methodology. We use continuous delivery. We push out changes, push them to master, they go straight out. It's great. But we want to be able to do that for an API as well, to be able to just push out our new features, get them to the client straight away. We don't want to have to wait 6 months or a year before our new features are coming out. We also want an API that is easy to maintain. If we have multiple versions with slightly different business logic for slightly different versions, it's a pretty bit of a nightmare to maintain. We want to keep our code base manageable and keep it sane. And we would like our users to have an incentive to upgrade. The ideal situation would be that all our users are always on the latest version, but that never happens. So we want to make it more enticing. We want our users to want to upgrade and for it to be easy to upgrade. So what do all of these things mean? To keep us happy, we need to release multiple versions so we can work in an agile methodology. But to keep our users happy, we need to keep all those versions stable and not change. So we basically need to release all the versions and support all of them, which sounds like a terrible idea. It sounds like we're going to have a spaghetti code base where there's lots of different branching, lots of different versions. Doesn't sound like a good idea. But there's a really nice blog post from Stripe, the API payment gateway, on how they do versioning. They use rolling point-in-time versions. These are versions that are named after the dates on which they're released. And these versions are actually treated like layers that they step through. So rather than having new sets of the API, the versions are actually just transformation layers. OK, so let's take a look at how this works from a user perspective. So a user is making requests to our API. So we have a user, we have a gateway. The gateway can be part of our application. It could be a standalone service. And we have a version data store, and we have the API itself. So the user makes a request to get a list of to-do items. They're just making a GET request, and they specify their API key just to identify themselves. Our gateway then looks up that version for that user. So we have their API key. We find out what version they're on. that returns their version. So we have that stored. They are using this date-based versioning, so it's 2018, 0125. And then we pass that through to the API, passing along that version. So when the request comes into the API, we know what version the request is in and what version the response should be in. But what if a user doesn't have a version set? What if it's their first call? So in this case, a user makes an API call again, passing in their API key, and we look up their version. This time, they don't have a version set. It's their first request. So we actually set the version for them. So we actually use the latest version at that time. And then we pass on that version to the API. So the API knows what version to expect and what version to respond with. What if a user wants to try a different version? So maybe we have a beta version, or they want to compare it against an older version. In this case, the user can actually specify the version themselves. So they pass the API key, the version, and we don't even need to look up the version this time. They've already specified it, and they get the response back in that version. If they want to change versions, they can take a look at their developer portal, see what version they're on. If there's an upgrade, they're notified. They can take a look at the changelog and see what is necessary to change between their version and this version. And they can simply upgrade through the portal. OK, so that's the general idea. How do we actually put this into practice? The first thing we do is we keep it current. So we keep our application on the latest version. So it's always running on the latest version. We make a change, we make it to the latest version. It's not like we've got 3 or 4 different versions of the application running. We've got one version, and it's always the latest. And then we release rolling date-based versions. So when we do make a change, we create a new version. And that version is actually a transformation layer to get from the latest version back to the previous version. So again, our application is always running on the latest version, and then all the other date-based versions are basically transformations that we go through to get from the latest version back to those versions. OK, so let's take a look at a request being made. So we have a user, and they're on version 6. And we have the API application running on version 7. And we have some version transformation layers for version 5, 6, and 7. So a user makes a request, comes in at version 6, because that's the version they're running on. That request is then transformed from version 6 to version 7, comes into our API application, running at the latest version. It's returned in the latest version. That is then transformed back from version 7 to version 6 and comes back to the user. So the user is running on version 6. The API is running on version 7. The user makes a request in version 6, gets a response in version 6, and the API is running in version 7. But neither of them have to know about that. We're just transforming the request on the way in and the response on the way out. OK, so let's take a look at how we can actually build this. We are using Elixir and Phoenix. Elixir is obviously a functional programming language, and it's great for transforming data. It doesn't need to maintain state, just takes data in, passes it through, transforms it, and is really good at transforming data. Phoenix is actually a great example of this. It's pretty explicit about how it transforms data. So we have the typical request lifecycle is we've got a connection that's being transformed through an endpoint, through a router, through a pipeline, through a controller. It's just being transformed as it flows through the application. And with the plug library, we can actually add into this pipeline. So what we're looking at today applies to anything plug-based. It's not just for Phoenix. A plug is a simple module that just takes in a connection and gives out a connection and transforms it on the way through. And we can actually use that to add some extra logic to this pipeline as the connection is coming through. So we can add things like authentication or versioning, because it's just a pipeline, and we're just transforming the connection as long as we take in a connection, give out a connection. And that's exactly how we are transforming our versions. OK, let's take a look at a sample application. So just a simple to-do app. It's just a JSON API returning a list of to-do items. So we have a GET request to return a list of to-do items. simple JSON objects with a title, ID, and a description. But we want to change our pagination parameter. So we have a size parameter that specifies the number of results we're getting back. And we have size equals 2, but we decide that size isn't a great name. So we want to change size to page size. So this is a simple change, but it's a breaking change. We can't just change the name of our request parameters without telling our users. Anybody who's using our API, their pagination is going to break. They don't know about the name change. So how do we deal with that? So we have a user. They're running on an older version. They make a request in the old format, so they specify size as the parameter. We can transform that from size to page size, so the new format, and then pass it into the application running on the latest version. We can implement this with a simple plug. So it's a plug, it takes in a connection. This actually pattern matches on the pagination parameter. So pattern matches on size, and it can just swap out size for page size, put it back into the connection, and pass it through. So we've just transformed an old request into a new request. If it doesn't pattern match, it'll just pass the connection through. What if we want to change something in the response? So we have our to-do items again. We have a title, ID, and a description. This time, we want to change the description field. We've decided that details is actually a better name. So again, it's a simple change, but people might be depending on that description field, and we can't just change that. So looking at it from the application perspective this time. The application is running on the latest version, and it returns the new response because we always make our changes to the latest version. So it returns a title, ID, and a description. We transform that response from the new response to the old response. So we're just basically changing details to description and send it back to the user who's running on the older version. So they get the old format. Again, we can implement this with a simple plug. Takes in a connection. This time it actually calls con.register before send. And this registers a callback to be invoked on the response before it's sent out. So after it comes through the application, but before it's sent out. And this time we've registered a callback called transform description. And what this does is it decodes the response, swaps out the parameter, so it swaps details for description, and then puts it back in, and then sends the connection on its way. Because this is just JSON, we can actually not bother with decoding the response. We can just do a regex replace, swap description for details, and send the response on its way. So this is just how we transform our response from the latest version to an older version. So just recapping the flow, we have our user running on the old version. They make a request in the old format. We transform that from the old format to the new format, comes into the application at the latest version. The application returns a response in the latest version that gets transformed back into the old format and back to the user. So again, the user is running in a different version to the API, but it's just transforming the differences in between. Okay, so obviously having a plug for each one of these changes can be hard to manage. We're going to have a lot of plugs. So we can improve that. We can create a behavior to model a change. So it's a simple behavior. It just has a transform request and transform response. Two functions. They both take in a connection, and they both return a connection. One transforms the request on the way in, and one transforms the response on the way out. And then we can group all these changes together with a simple map that is a collection of our versions. And these versions are the changes that are necessary to get from one version to another. So we're on the latest version, and to get back to one previous version, we look at the changes that are necessary to get from the current version to that version, and from that version to the next version, and so on and so forth. It's kind of a similar idea to like Rails migrations or Ecto migrations. We're basically just transforming one step at a time. Okay, so then once we have our versions, to actually get the necessary changes, we can take in a version. We can just enumerate over these because we're using dates as the versions, as the keys. We can order them and get the correct list of changes necessary to get from the current version back to that version. And then to actually use this, we can just create another plug. And this time the plug does all the versioning for us. So this plug will do a number of things. It will get the request version, it'll get the changes for that version, apply the request changes, and apply the response changes. So looking at that, just a naive implementation, we would get the version from the header and then get the collection of the changes that are necessary to get from the latest version to that version. And then we would apply all those changes to the request. So we're just enumerating over that collection of changes and applying the transform request. And then we do the same with the response changes, except instead of applying them, we're just registering the callbacks that'll be called on the response just before it goes out. And that's kind of the general implementation of the strategy. It's pretty simple. There's actually a library that does a lot of this for you. We saw how easy it is to implement, but if you want to give it a quick try, there's a really nice library called Multiverse. It's written by Andrew Dryga. It was kind of an inspiration for how we're doing versioning because it was so simple to do. And it was an inspiration for this talk. It's really nicely written, and it's well worth checking out. It defines behaviors for your changes and uses a plug to apply the correct changes for your request or your response. Okay, so those two changes were pretty simple. We were just renaming some fields, but it's not always that easy. When we were initially investigating this as a new versioning strategy, we wanted to be sure that this was going to work for us. It's a pretty big undertaking to make a change like this. So we actually went through our change log for the previous 6 months, and we went through all of our changes and tried to apply this strategy to those changes to make sure it would actually work. So I can kind of quickly run through a few of those changes, a few of those examples, and we can see how it works. So the first example is, let's say we are changing a route between versions. We had this endpoint to get a list of to-do items, and we want to change that endpoint from /todos to /to-do items. We can use our change behavior. We can implement that and change the request. This will pattern match on the old route. So it's pattern matching on API to-dos. And we can change the path info attribute of the connection. And this is what we're using internally for the request routing. So the user makes a request to the old path, and internally we will reroute that to the new endpoint. It's pretty simple. And because we're using pattern matching, if the new URL is used, it doesn't hit this. But also, this change is only going to be applied to older versions. So new requests don't even go through this. Let's say we want to create a new route only for newer versions. Maybe it's a beta feature that we don't want to release to all clients yet. So we have an endpoint that we want some users to be able to hit, but other users should get a 404. We can do something similar to what we did with the previous change. So this time, we're pattern matching on that route. But for the older users that we don't want to get this, they will come into this change module, and we will actually reroute them to a path that doesn't exist. So this is a path we've predefined as a not found path. They will actually receive a 404 for their original request path, and internally, we reroute it to a path that doesn't exist, and it just uses the default 404 behavior. Okay, let's say there is a route that we want to remove. Let's say there is some functionality that we no longer wish to support. We're just getting rid of this completely. Unfortunately, this one isn't solved by a versioning strategy. We can return a 404 to all the latest requests, and then continue to support that for the older versions. But that doesn't get rid of the functionality. We need to continue supporting that. If we wanted to really get rid of it completely, we would still need to deprecate this endpoint. I mean, this isn't the silver bullet fix for everything. There is still issues with this. But at the same time, this is a problem we would have with our existing version strategy. We still need to deprecate things if we're using major versioning in the path or at the header. Let's say we want to remove a field from the response. So our response has a title, ID, and a description. And we want to get rid of the tags field. We could remove it from the newer versions and continue to return it in the older versions. That would work fine. But again, we would need to continue supporting that in the older versions And in this case, in this change that we were looking at from our changelog, we had to remove this field due to copyright restrictions. So what we could do here is we can actually return a safe empty value so that for the newer versions, we get rid of the field. That's fine. But for the older versions, we can actually return an empty value, a safe empty value that doesn't break their integration. So we return an empty array for the list of tags so that we're keeping our legal happy by getting rid of the field, but we're not breaking the API integrations. Okay, one last one. Let's say we have a validation change. We have our title, and we have a max length of 50 on that title. And we want to change that from 50 to 30. This one isn't so easy to deal with because it's not about the request or the response this time. It's some internal business logic to our application. So how do we deal with this? We are expecting a change set to come in for this to-do item. So it's either a put request or a post request. We can actually merge our version into that change set so that when the change set comes in, we know what version that change set is at. And then in our application, we can define some functions that provide different values for different functions. So we can say any of the newer requests will have a version or a max title of 30, and any of the older ones will be 50. And then when we're actually applying our chain set, we can call that dynamic validation field, so it actually returns the correct validation for that version. So it's a little bit more work, but we get there. Okay, enough of the code samples. I think you kind of get the idea of how it works at this stage. But earlier on, I mentioned a few key points that we were aiming to improve. We wanted to try and make things better for API consumers and us as maintainers. So let's revisit them. Okay, our users wanted a stable API. And because we've made versioning easier to manage, we can afford to support the older versions. Users can sign up. They can get assigned a version, and it'll continue to work even when we're multiple versions ahead. We are free to change the API, push out new features to new versions without affecting the older ones. We are using Swagger for our documentation. We're using the Phoenix Swagger library. And the nice thing about Swagger is that it's just a JSON file being loaded into the UI, or they can create a client from it. When we create a new version of our API, we actually create a new version of this JSON file. And when our user is logged into our developer portal, we know what version they're on, and we can serve the correct Swagger for them. Of course, a user can always swap between versions, but by default, we always show them the correct documentation for their version. For those users who don't want to deal with versioning, this is the perfect setup. They don't need to specify any versioning. We look it up for them, we assign the versioning for them. They only need to deal with versioning if they want to upgrade or if they want to compare against a different version. Those projects with a third-party development team, they will continue run as they were initially built, and they don't need to change anything. Our API is easier to upgrade. We don't have a 6 or 12 or 2-year-month release process where they have to deal with all of these changes at one time. The changes are smaller, more granular, and easier to deal with. New versions can easily be tested by changing the version header or testing a beta version, comparing against an older version. So I think we've definitely hit some of the requirements we were looking at for users, but how does it work out for us? So we wanted an API that was easy to change. And using this process, we can definitely stick to our agile methodology and push out new features to our API. We can continue with our continuous delivery, push out new features to master branch, and the users will get them straight away. We don't need to save up our changes for a year. We don't need to worry about breaking things because it's only the latest users who will get those changes. We capture everything in our changelog, and we keep our clients informed. We keep our changelog visible so that they know what we're working on. They can see the new features coming out, showing that we're always improving things. And this in itself provides an incentive to upgrade. By making our changelog visible, making it central to our documentation, it's more enticing for users to keep up to date with the latest versions. And because it's easier to upgrade, we've made the process, the barrier of entry or the barrier of change easier. Upgrading is an easier process. And we also allow our users to upgrade, not to downgrade, kind of which continues to push them forward with the versioning. I think we have definitely kept our code base more manageable by doing this. We don't have any ifs and branches and conditionals based on the different versions. We don't have different business logic for the different versions. We have one version, the latest version, and we have some transformations that are isolated and separate to this. Those transformations can also be easily tested. They're just simple functions that just transform the data, and we can test that pretty easily. But in saying that, I mean, there is obviously a certain amount of overhead with this strategy. As you saw, there are some changes that are more invasive than others. Our versioning has to become a first-class citizen of our code base. It's built right into the business logic. But for us, the amount of overhead that this does add, coupled with the consumer happiness, is still a better idea than the traditional versioning. It works better for us. Okay, so if this is so great, why doesn't everybody do this? I mean, I did some research, and there was really just a handful of companies actually using this. And the thing is, I mentioned at the start that versioning is hard. It's a hard problem. And in this case, we deal with the pain instead of the customers dealing with the pain. Somebody still has to deal with it. It's a big commitment to support older versions and to continue to support older versions. Stripe, who pioneered this versioning strategy, are still supporting versions from 7 years ago. So from when they first started with their API, you can still make requests with that version. And there are a few other drawbacks. If we don't limit the amount of versions, there is potential for the requests to slow down. There's going to be more transformation layers for things to be transformed through. And while these versions can be easily tested in isolation, if we have some integration tests that are making real requests to our API and we're checking the responses, then we actually need to have multiple versions of those integration tests as well. So, final thoughts on this. I think it depends a lot on your users on how you version your API. If you have technical users, technical API consumers, then maybe they can deal with the upgrade cycles of rewriting things every 6 months, every 12 months. Another alternative is GraphQL, which solves a lot of traditional REST API problems. But we actually had a version of our API in GraphQL, and our customers couldn't use it. A lot of them wanted a SOAP API, not even a REST API, so GraphQL was way too far away for us. But overall, so far, this has worked really well for us. But the thing is, just because we can change things doesn't mean we should change things. If we have 40 API versions that users have to transform through, then that's a code smell. You're doing something wrong. You're designing your API badly. 40 breaking changes is a lot. And the thing is, while we can change things, we shouldn't change things. We should still be thinking about how we are building the API, making the correct decisions, designing it correctly from the start. Just because we can change it doesn't mean we should change it. So yeah, that's pretty much it. That's all I've got. If you want to find out more about what we were doing at Meltwater, you can check out our tech blog at underthehood.meltwater.com. I'll probably get my slides up there pretty soon. But yeah, any questions, I'm happy to get some feedback. One here.
Raise your hands again.
Are there any types of changes that you found you have been unable to do given this framework?
As I said, we went through the changelog and actually implemented everything. The one that I did say that doesn't fix, if you want to remove something completely, then yeah, we can't do that. We still have to deprecate it. But that's also a problem you have with other APIs. One of the nice things with our API is that we're not depending on a database. I think if you make some bigger database changes, then maybe these things aren't as easy. If you have a field that you're removing or you don't want to return in the newer versions, then you probably still need to return that in the database calls. Are you going to be making calls in your transformations, which isn't ideal. But for us, that wasn't a problem.
And then I guess as a follow-up to that, have you thought at all about what you would do in one of those situations where there is a larger sort of structural change? Like, have you sort of thought ahead enough to think about how you would try to deal with something like that if it came up? Or is that sort of a methodology thing, and you, knowing that you have this framework, you sort of work in ways that work with the framework?
I mean, so far we haven't had the problem. Like I said, we had about a year's worth of beta changes to go through, and that was enough for us. That was enough to validate that it works. I think we'll take these problems as we come. There's no point in kind of prematurely optimizing.
Cool, thanks.
Thanks.
Hi, great talk. I think this is a really good approach. Near the beginning of the talk, you showed the example of transforming the key of the object in the response. And it looked like you were doing like a string replace on the response. And I could see how if you're doing the way that you were registering the callback before the send, if you're dealing with the string already, then your options are kind of limited there. You kind of have to be transforming the string. Have you looked at other approaches where you'd somehow introduce a transformation when it's still an Elixir data structure before it's been serialized?
Not yet, no. I mean, right now we're just dealing with the responses and requests as they come in, and we're just transforming the data. It's pretty basic, really.
Do you find that, sorry about my voice, do you find that with some of the older transformations that there's sort of a threshold that's hit with the number of users that you actually go to those users and say, it's time to upgrade? Or are these low maintenance enough that you can essentially set them and leave them there for eternity?
So right now we've been using it for 6 months, so it's still pretty new. We haven't really got enough versions. In fact, we are still trying to design things carefully that we don't have 40 or 50 versions to go through. That's what I said is kind of the important thing is still to design the right API endpoints. But I did mention that we allow users to upgrade and not to downgrade. And we do kind of reserve the right to deprecate those older endpoints. We're keeping stats on all the API calls and all the different versions, so we can tell when nobody is, when users are no longer using the versions. It's also stored on the users' profiles what version they're on, so we kind of know when an API point version is no longer in use, and I think we could always look at deprecating those if we want to.
Hi, great talk. As a kind of a thought experiment, I was wondering if anybody's considered composing versions or cherry picking them, if you will. Say maybe a new version has a whole new entity that's coming down, but you don't want to do the upgrade for all the other changes in between.
Yeah, I mean, with the way we're transforming between versions, it wouldn't be so easy. You would really need to, there's one version that you want, you would need to get to the versions in between as well, because we're transforming from version to version. We're not transforming from one point to another point. You have to step through all those parts in between. So you basically, it's just one transformation between versions.
Any more questions? Oh, sorry.
So there's some literature out there about how to do like safe database schema migrations, et cetera. I'm wondering if there's any documentation you found about like best practices about API versioning, maybe from Stripe or from your company.
To be honest with you, I did mention there's not that many people doing this. Stripe were the only ones I could actually find any documentation on this from. That blog post that I referenced is pretty much that, and there's one talk given by a Stripe engineer on how they do that. So this is kind of, when we first started doing this, I was a little bit worried why nobody else is doing this. And that's why we went through our changelog and tried it on everything, because I was kind of surprised that there's nothing out there.